to everybody. As motivation, why is the analysis so important? Just imagine you are a design engineer at a company, maybe for this power tool, and you develop the product and give it to the manufacturer, and the first prototype comes back, and one part is and you make some tests, and the first test and one part broke. What do you do at first? You can run a simulation, you can coarsen the part, you can change the material. There are so much possibilities, but at first you should identify the problem cause. What is really the cause of this problem, to find a perfect design solution for it. And some design engineers are really good at analyzing and finding these problem causes, and other design engineers are not. We wanted to study why are there successful design engineers and why are there unsuccessful design engineers, and how can we help the unsuccessful design engineers. So we took a look in the research, and there are quite a few studies on functional analysis. But by the term functional analysis, it is meant that participants should analyze the intended function of a system which is prior unknown to them. So they get like this polygon, and they should analyze the embodiment of a system and conclude to the intended function of this system. And the overall strategies, like follow the flow of energy, are known, but it is still unknown how participants analyze the small functions of different subsystems. And the functional analysis also misses a part from design engineering, because it is only the analysis. There is no synthesis on the next iteration, so it is only analysis of the intended function. There are also studies on the whole design process, which also covers the synthesis, but during these studies only most time they focus on synthesis. They also record analysis phases, but they never go in depth for the analysis phases. RuPaul et al. Introduced the term synthesis-driven analysis, and which also covers the synthesis, and the analysis in design processes is always driven by the synthesis, because the design engineer wants just analyze enough to gain knowledge to synthesize the new iteration. But also there, the overall strategies and also the micro strategies are unknown. Therefore, we set up this research plan. We conducted an explorative study, and the results I will show you in the presentation. After that, we tested the formulated hypothesis in the main study, and with all the knowledge we designed a method to support the analysis and tested it with 12 participants. In this presentation I will show you the answer to the research question: what are design engineers and students' successful approaches to analysis in design processes? Next, I will show you the experimental setup. This is a typical setup for our studies, and we had some with different subjects, task, data, methods of data acquisition, and I will show you how we analyze the data. First, in this study, we had 4 mechanical engineering students and 3 design engineers with different working experience. And we had 2 tasks. The first task was a functional analysis of a lawn sprinkler. The participants had 10 minutes time to analyze the function, and afterwards the participants should describe how the lawn sprinkler works. And in the second task, you already know the example of a broken part in power tool. The task for the participants was to further develop this power tool so that the part doesn't break anymore. And it is hard for the participants because the part does not break because of its main function, but of the strong recall of this power tool. And therefore you have to overcome your own limitations and think outside the box. So the analysis was not explicitly required. The task was to improve the system's design so that this malfunction doesn't happen. For methods of data acquisition, we used an SMI eye-tracking clusters to record the visual attention of the design engineers. And therefore we could analyze which design characteristics are being looked at and analyzed. And simultaneously we asked the participants to think aloud. So out of this information we could extract which function or which behavior is recognized by the participants. And in the end we had a questionnaire so that we could compare the analysis success of the different participants. And here is a video of a participant analyzing the lawn sprinkler, or part of it. And although that he should think aloud, he doesn't do it. But with the eye tracking we can still see which parts we're analyzing. And in the end, he gets there to that he analyzed the function and understand it. And now we can analyze at which part do they recognize which function. We transcribed all the audio from the Picolot, coded the functions which were analyzed, and from the eye tracking we had the information in which parts the participants looked. And also we coded the Picolot on whether the participants had doubt in their analysis, or if they were absolutely sure about the topics they were talking about. And now let's come to the results of this study. We could identify 3 micro-strategies, as we named it. So the micro-strategies are good for this unknown subsystem in the whole system, and the participants don't know what is the function of this subsystem, and then they have the possibility to use 3 different microstrategies. And if they don't conclude on the function of this subsystem, first way is to zoom in, so to focusing only on individual components, on contact surfaces, and really narrow it down, only analyzing a small part of this unknown subsystem to perform the deeper analysis. Here we have a look on this microstrategy. The participant is analyzing the whole subsystem, and now he wants to verify one assumption, and therefore he analyzes only one part, and especially only the broken surface to conduct to the how the part is broken and also from which direction he forced and pushed on this part. And of course, if you can zoom in, you can also zoom out. So some participants enlarged their examined section, and so they could consider exterior influences from the environment or from other subsystems. And the third microstrategy is called shift. There the subsystem isn't looked at, but only the nearby subsystems are looked at. And the participants analyzed the input and output of the nearby subsystems and conclude therefore to the function of this searched subsystem. And another goal of this study was to come up with hypotheses to test in the main study. And I'm going to present you two hypotheses. The first one is we saw that a lot of assumptions were made on functions and possible causes of problems. And we also saw that the students usually followed their first assumption. They came up with one cause for the problem and directly developed a solution for it, where the engineers were more aware that their assumptions might be wrong, and therefore they searched alternative explanations for this problem cause. And they also stated more comments where we could identify doubt. So almost 2 times more statements where we identified doubt in their expression. And the engineers also used various evidence to verify their assumptions. Therefore, we came up with the hypothesis that verifying all assumptions about function and behavior of the technical system improves the quality of the analysis. And the second hypothesis, we came up with this idea for this hypothesis during the first task, lawn sprinkler. The participants analyzed the function of the lawn sprinkler, and in the end they should describe the function to the experimenter. And 3 out of 4 students were not able to identify all the functions. But they believed they did, and they realized this mistake when they were explaining the function to the experimenter. They explained step for step the function and identified their own gaps and mistakes in their understanding of the system. So, therefore, we came up with hypothesis 2. A structured enunciation of one's own understanding helps to identify gaps and mistakes in the analysis. Which is, in my opinion, a great deal, because nothing is so hard than identifying own gaps and mistakes in the understanding, in one's own understanding. So let's come to the conclusion. We identified these 3 micro strategies and demonstrated that there are 2 possibilities to deal with problems. You can either change your heuristics or you can change the problem. In my opinion, the micro strategies were for both of these tips, because in order, when you use one micro strategy, you change your heuristics, but you also change the problem or the part of the problem you're looking at. And as I mentioned earlier, we already performed the main study in the time from writing the paper to now. And we found strong support for the hypothesis that verifying all assumptions really makes the analysis better. And also the procedure is almost obvious. Almost no student used it. And there were also design engineers which didn't verify their own assumptions. So therefore we see a clear need for training, especially with students, but also by design engineers, because nothing is more useless than solving the problem, which isn't the real problem, because you identified the wrong problem cause. And for the structured enunciation, we didn't find any support for this hypothesis. Only one of the 24 participants found a mistake or a gap in his own understanding. And maybe it is on the difference between describing the system's function and explaining. The participants in the first study really explained it step by step, and the participants in the main study only described retrospectively what they analyzed. And therefore we are still on it to go deeper in possibilities how we can help design engineers to structure their analysis and how to identify own gaps and mistakes in the analysis. That's all. Thank you for your attention. And
thank you, Thomas. We've got information that we have time for a small question if something would not be really clear, because the last Skype presentation that was planned is cancelled, so we have some more time. So if there might be anything that's not really clear at the moment, then we can just have a few minutes.
Actually, I just have in your opinion, you got these three, zoom in, zoom out, and basically the flows, right? The input, the output. Which would you, I think all three are necessary, right?
yeah.
And which would you think is the right order to do it? I mean, I as a professor, I would tell my students, oh, you should first have the overall system, and then you should look at the flows, and then go inside. What is your strategy best one, you think?
I don't think that I cannot say which is the right order, because it always depends on the problem, on the system, on the participant. We use it to teach students that there are these three possibilities and that they choose their own approach, but that they know that there are these three possibilities. If you encounter a subsystem which function you can analyze, here we have three possibilities. Choose one and test it out.
There are only three, there are no more.
Yeah, because you can go deeper, you can go higher, or you go away. There are no more possibilities. But in my opinion, it helps if you encounter a problem and you think, I can do it. Someone comes and say, hey, there are three ways, and only three ways, just try one. Just to overcome this burden that you say, oh, I can't do it anymore.
Of course, and I think it is a combination of this, and they change very quick between the strategies. So this is important to understand.
Yeah, I have a question. You use eye tracking, so the heat maps that are created, are you correlating them to the hypothesis that you try to find? Like, is there a correlation? Because I could not really see that. I mean, can you really actually see where the participant is looking at, and that might already sort of reflect that he's looking at the wrong part or the wrong functionality, and missing then the realism? Is that something that you do, or did I not understand it?
We did this kind of research,
Yeah.
but it is very hard because it is always bounded to one system, to one problem.
Right.
I can come up with ideas with facts like the most successful engineers look at the broken part and on the surface. I can give you this information, but it doesn't help you anything with the problem on the lawn sprinkler or other problems. So we focused more on the approaches of the participants rather than where they, which parts, especially on these systems they looked.
So would that
we use eye tracking especially to gain a better understanding on the procedures, not on, especially on the high facts, how many milliseconds did they look at this part or at this part. So more on the approaches and to gain a better understanding, what did the engineers do.
But in that same line is then the use without the eye tracking, you would probably get the same results. Is that right, or
almost? Also, we started with eye tracking.
Yeah.
We wanted to do exactly this, the facts that you missed. But we came up with that the eye tracking is, especially with this, it is hard because the system is, you can look from every side on it. I think eye tracking is really good to analyze more static stimuli.
Mhm.
So like if we had a blueprint of this system, eye tracking would be much easier to use, but you can use eye tracking much easier, and the information you can get out of it is much better than with this.
so a HoloLens would work maybe?
Sorry to interrupt, maybe we can continue this discussion after the rest of the presentation, because otherwise we would have a time problem.
Too bad.
I would like to introduce the next speaker. Thank you for your nice presentation, by the way. Our next presentation lies down